Hey guys, welcome back to part two of 9.1. So one thing that dawned on me in the last lesson was checking our calculators to make sure it was in the right mode, or just showing you guys real fast how to do that. I had posted a free trial or a free 6-month download for a TI Inspire. So let's go over that one more time on how to basically change it in the right setting. All right, so basically you want to go to the home screen and then go to settings, which is number 5 here. Go to document settings, and then where it says angle measurement, you want to go to degree. Now, if we had completed all those problems on part 1 with this calculator, we would have gotten all the wrong answers because it was on the wrong angle measurement. But I just used my own personal calculator, so everything was good. And then once you have that switch to degree, just you can either say make default or say okay. It doesn't really matter, just as long as you're able to change the setting for right now. All right. So what we're going to move on to in the last part of this lesson is something called inverse trig ratios. Really, all an inverse trig ratio is used for is to find a missing angle. All right. So I want you guys, especially with trig functions, whenever you see a -1, come on, the -1 here, all that's really going to imply is that we're trying to find a missing angle, missing angle using the sine function. Okay, so we're going to get in that here in one sec, but this is a lot of information, but really the same thing holds true for all these ratios. So inverse sine, inverse cosine, and inverse tangent are going to have the same exact guiding principles in terms of setting it up and finding the missing angle. Now, if you look at example 5 here, it says find the measure of each angle. Well, the problem with this one right now is we have only the right angle given, which might make it hard because we know that all the angles of a triangle add up to 180. However, we only have one angle given, so we can't really manipulate just that angle to find the missing one. So instead, we need to use a trig ratio, and more specifically, the inverse of a trig ratio. So the angle that it wants me to reference here is n. Right, that's what we're trying to start with, or that's what we're using to find which ratio we need to use here. So once again, you think of it the same way while you look across. That 6 is going to be your opposite side, and then the 10 here is your longest side that's across from the hypotenuse, or sorry, across from the right angle is your hypotenuse. So we have O and H, meaning that's going to be our sine function. Now, the way I'm going to write this is I'm going to start off with sine theta, so maybe I should have labeled theta right here. Sine theta equals 6/10. Okay, 6/10. Now, unlike the last few examples, we had to solve for a missing variable by multiplying something over or dividing a trig function over, or whatever the case was. Now what we need to do is use the inverse trig function. To do that, it's real simple. All we're going to do is we're going to rewrite this as sine inverse. Right, that's what the -1 represents, is inverse. We're going to do sine inverse of 6/10 equals theta. Okay, equals theta. So in other words, you're basically just kind of flipping these two, right? The fraction with the variable just basically switches spots. Okay, now let's go ahead and look at typing this in using the TI Inspire calculator. So I'm going to go ahead and go here. Okay, let's go to add calculator at the bottom. Okay, we're going to do the trig button. Oops. Okay, we're going to, that was weird. Okay, we're going to go to the trig button that has sine with the -1. That's what the sine inverse is. And we're just going to do 6/10. And 36.8699 is going to be the angle. Now, depending on what the problem is or what type of assignment it is, Some people will want you to round it to the nearest whole angle. Some people will want you to do 1 or 2 decimal places. For right now, let's go ahead and just do, we'll say angle N, or we'll say theta, I guess, first. So theta is going to be equal to, that was 36.87. That was what, how I'm going to write it. 36.87. Okay. All right, and actually, so I just realized here, our directions say round to the nearest tenth. So let's change that to 36.9. All right, so now that we've established that, we now know, using this right triangle again, that this angle now is 36.9, okay? And we know all the angles of a right triangle add up, or just a triangle in general, add up to 180. So we have a 90-degree angle, plus our new angle, which was 36.9. Whoops. 36.9. Okay. And we're going to take 180 minus that angle to find what the remaining angle is to get our missing angle. So that's 53.1 is going to be the missing angle here. So angle L, right, because this is L and M, so that's 53.1, and now we've found all the missing angles, okay? All right, so let's go ahead and do one more together. I'll talk about one more at least. Now, I guess looking back at the directions, I'm not sure if we needed to find both angles, because notice how it just says angle N, but it's good to know how to find both anyways. All right, so now we move on to this one, and we're trying to find this angle here. So just for time purposes, I'm going to go ahead and write these out. This is A over adjacent and hypotenuse is those two side lengths, right? So that would be your cosine function. So I'm going to do cosine B or cosine theta. It doesn't matter which variable you use, as long as you set up the right ratio. That would be 8 over 16. Okay, you can simplify it down to a 1/2 if you'd like, but it doesn't really matter when you type it in. So this would be cosine inverse 8 over 16, right? Because we're finding the angle. There's your inverse. So then you would have B is over here. Okay, so let's go back to our calculator. Let's type in cos inverse of 8 over 16. I'm going to show you guys, we could have simplified it down. So notice the angle provided is 60. Let me go back to here and let's type in 1 over 2 just to see how they compare, right? Because all trig functions are relationships of the side lengths. Well, if the ratios are the same, then the angles have to be the same, right? 8 over 16 is the same thing as 1 over 2. So now we've established angle B is 60 degrees. Okay, well, we could easily find A if we wanted to. That would just be 30, right? Because 60 plus 90 is 150. And you take away that from 180, and that would give us 30 degrees. So that's our other missing angle, even though it wasn't necessarily asking us to find that. All right, so, and actually, I guess over here, let me write that piece out that we did. We had 90 plus 36.9, okay? That equaled 126.9, and we subtracted that from 180, and that gave us our 53.1. Okay, all right, go ahead and take a second to try these two problems on your own. Notice we're finding the missing angle, so that's using your trig or inverse trig function once again. All right, so go ahead and take a second to do that. All right, I'm going to go and write these out. So we have our adjacent side and our hypotenuse. Okay, so that's once again cosine, and we'll put x here. We have adjacent over hypotenuse, 15 over 17. Cosine inverse of 15 over 17 is what we would have. Okay. Some students have also asked, is it okay if we just go from here to this step. Yeah, that's fine. If this is something you're picking up on pretty quickly, I'm just showing you guys that normally you just write out the trig ratio first like that. But absolutely, you can do it that way is completely fine. Type that into your calculator. So that'd be cos inverse 15 over 17 and 28. And we'll round it up to 28.1 is going to be the missing angle. So 28.1 degree. Okay, next one, we have our opposite side over here. We have the adjacent side here. That would be your tangent function. So we'll have tangent x, right, because we're comparing from that angle, right, just like we were comparing from that angle in the first triangle. 27 over 18 would be your ratio, okay? And then tan inverse 27 over 18. And let me go and type that in as well. Tan inverse 27 over 18. And 56.3 is that missing angle. All right, and that is how you find missing angles of right triangles given two side lengths, just using the inverse trig function. All right, the very last piece of this lesson is going to be kind of tying into what we just learned called angle of elevation and angle of depression. So the way I always thought about angle of elevation and angle of depression is you basically think of, so say you're standing here looking way off in the distance, okay? And we're going to use a horizontal line as our reference point. Well, if you are looking up at something, say maybe like a bird flying by or an airplane or something like that, that would be your angle of elevation, right? That's the angle, of elevation. Now, if you're looking down on the ground, say you saw something on the ground, so you're looking down from your horizontal line right here, okay, then that would be your angle of depression. So just so you understand the difference between the two, sometimes it's not as obvious when you first learn about it, but that's essentially what we're looking at here. Okay, so let's move on to our last example. It says a golfer is standing at the tee, looking up to the green on a hill. If the tee is 36 feet lower than the green, the angle of elevation from the tee to the hole is 12 degrees. Find the distance from the tee to the hole. Notice how this is already set up perfectly for us as if we had just completed some of these right triangle problems. I guess this is more from part one, but it's asking us to find the distance from the tee to the hole. Oops. So notice the hole is going to be right here, and we are standing right here. So we're trying to find this missing side. That's the closest distance from the tee to the hole. So if we think about the angle that's given is 12, we have our opposite side here, and this is your longest side across from the right angle would be your hypotenuse. So which trig ratio requires us to use opposite and hypotenuse? Yep, that'd be sine, right? The SOHCAHTOA. So sine of 12 is what we put here, equals 36 over x, right? Opposite over hypotenuse. Well, here's another one of those weird examples where we have the variable in your denominator. That didn't work out very well. We have your variable in your denominator, so that's where you have to actually get rid of the denominator first, right? You can't solve for a variable if it's in your denominator. So let's get rid of those x's. Okay, so now we have x times sine of 12 equals 36. And what was our last step now to solve for x? If you're multiplying it by a sine or any kind of trig ratio, yep, that's going to be divide sine of 12 to each side. All right, so that cancels out. All we need to do now is type in this right side into our calculator. So we'll have 36 divided by, I think it was what, sine 12. sine of 12. And push enter, and there is our answer. So we are 173 feet, approximately 173 feet from the hole. So you golfers out there now know how you can find how far you are from the hole, because obviously this is what we think about when we're golfing, right? We think of right triangles. Totally kidding, totally kidding. But there is your answer. Any questions? Then go ahead and send it to me. You can message me or email me. Message me through Remind. I'll also have my tutoring hours posted if you guys have any additional questions. But yeah, that is it for our first lesson. So good luck on your homework. Let me know if you need any help, and we will go from there. Bye, guys.